wabarakatuh. My name is Nur Farah Aintina binti Abdul Rahim, number metric 299444. For the first question, for a monopolist, the average cost FC of producing a units of the product is Rm 3 ringgit, and the demand equation is price equal 10 divided square root of x. So the first question is find the total profit by S function. So as we know, profit equal revenue minus total cost. The first step is we need to find the revenue, that price times quantity. So we have a price, so we need to times price 10 divided of square root of x times x. So we get the answer 10x divided square root of x. The next step is we need to find the total cost. Total cost equal average cost times 2x. So Rm 3 ringgit is average cost, and we need to times with 8. So the answer is 3x. So the last step to get the total profit, we need to revenue minus to total cost. That so the answer is pi x equal 10 square root of x minus 3x. What price will give the greatest point? So we have a profit function, and we need to differentiate the profit function. So we get the 5 divided square root of x minus 3. To get the greatest profit, we need to pi prime s equal to 0. So 0 equal to 5 divided square root of s minus 3. Minus 3, we need to move to right side. So we get 3 equal to 5 divided square root of s. Square root of s and 3, we need to change the place, and we get the square root of s equal to 5 divided 3. Square root, move to left side, we get square. So x equal to 5 over 3 square. So the last answer of s equal to 25 divided by 9. When we get the s equal to 25 over 9, so we need to substitute the value of s to the p equation. That the equation is p equal to 5 divided square root of 25 over 9. So we get the last answer is Rm 6.
Hi, Assalamualaikum warahmatullahi wabarakatuh. I'm Shami Farhi binti Muhammad Razif, and my metric number is 299907. So today I will discuss about the question that I already solved, and I will explain to you on how I do it. So I did the first question, but the part 3, it say that prove that profit is at maximum using the second order condition, which is SOC. So for this question, we already have the equation, which is pi open bracket x close bracket equal to 10 square root x minus 3x. So what are we gonna do is we need to derive it first. So by using the equation we used earlier, we will derive it till we get pi prime open bracket x close bracket equal to 5 over square root x minus 3. So this is the first derive. But for the question, they asked us to do the second order condition, which is SOC. So we need to derive it again. So after we derive it for the second time, we will get pi double prime open bracket x close bracket equal to negative 5 over 2 x power of negative 3 over 2. So after we finish derive the equation and get the pi double prime open bracket x close bracket equal to negative 5 over 2x power of negative 3 over 2, we need to put it in a new equation. So for this for the next step, we need to substitute x equal to 25 over 9 that we solve in question number 2 and put it in pi double prime open bracket x close bracket. So the new equation will be pi double prime open bracket x, we will change it to 25/9 close bracket equal to -5/2 times 25/9 power of -3/2. So we need to solve the power of -3/2 first. So we will get pi double prime open bracket 25/9 close bracket equal to -5/2 times 27/125. 27 and 27/125 is the answer after we solve the power of -3/2. So we need to solve the equation and we will get the answer pi double prime equal to -27/50. So the final answer will be pi double prime open bracket 25/9 close bracket is lower than 0. So the second order condition, which is SOC, is satisfied, indicating to the local maximum.
Okay, question 2b stated that the manufacturing cost of an item consists of 6,000 ringgit as overhead, material cost 5 ringgit per unit, and labor cost Rm x power 2 per 60 for x unit produced. So the first question, they ask us to find the total cost Cx function. We just need to sum up the total of overhead cost, material cost, and labor cost. So as we can see here, for the total cost function, I get 6,000 plus 5 ringgit and x power 2 per 60. So for the total cost function, I get 6,000 plus 5x plus x power 2 over 60. So next question is question B2. They ask us to find how many units must be produced so that the average cost is minimum. So to find the average cost, we need to divide the total cost with the quantity. So from the total cost function that we get just now, which is 6,000 plus 5x plus x power of 2 over 60, we need to divide by x, which is the unknown quantity. So for the AC prime, we get 6,000 over x plus x over 60 plus 5. So we can rephrase the equation by make it like 6,000 over x power of 2 plus 1 over 60 equal to 0. Then for the equation, we can settle it by doing a cross multiplication, which is we can get 6,000 multiply with 60 equal to x power of 2. So we can get 360,000 equal to x cubed. And when we use the a power to settle to get the x, so we can get x equal to 600. So for this question, I get the answer is 600. 600 unit will be produced in order to make sure that the average cost is minimum.
To determine whether the average cost function ACX is increasing or decreasing within interval 0 infinity. Firstly, find its derivative AC prime x, and then setting this derivative equal to 0 to find the critical point, and then we solve x and resulting in x equal to 600, and then we analyzing the signs of AC prime x, and we find that for x less than 600, AC prime x less than 0, indicating ACX is decreasing. For x more than 600, AC prime x more than 0, indicating ACX is decreasing. Therefore, AC decreases on interval 0, 600 and increases on the interval 600 infinity. In part B4, we are asked to find the rate of increase in total cost. Given the cost function Cx, differentiate the cost function Cx with respect to x, then apply the differentiation rule. And lastly, we simplify the expression.
So for question 2, which is part 5, the last question, they asked me to refer to the answer for question 4, explain your answer. So based on the answer from the question 4, we can see that the rate of increase in total cost is C prime open bracket x close bracket equal to 5 plus x over 30 represent the marginal cost. This expression shows that the marginal cost is not constant and increases linear with the number of units produced.